One of the main focus of algebra is to solve equations with variables. This section is all about solving single-step equations, meaning there's only one step we need to do to get the variable by itself, which is how we solve for a variable. First off, let's look at this first one, x plus 3 equals 7. Now, if you look at that, you're asking what plus 3 equals 7? And you may know that, well, 4 plus 3 equals 7. Which is true. That means x equals 4 is the solution. And that's what we're looking for here. We're looking to make the balance on both sides of the equation. Now, x is a variable. It can be kind of whatever you want. But there's only one value for x that makes this equation true. And that is what we care about. 4 plus 3 is 7, and 7 equals 7 is a true statement. So, x equals 4. For the next one, what times 3, or 3 times what, equals 15? And thinking about it, you may find, well, b must equal 5. 3 times 5 is 15, so that's the value that we want to know. And 28 divided by what equals 4? Well, you think about it, well, d must equal 7 here. In all of these cases, you're just kind of like guessing and checking, which it works if that works, right? That it's good that you can do it that way. But a lot of times we deal with equations that are not so easy to check. For instance, if we had negative 3.297x equals 45.6. What value times negative 3.297 equals 45.6? This is not easy to guess, but we can solve this using algebra quite simply. This is a single-step equation, and at the end of this video, you should know how to solve it. Now, to solve, for instance, this first one, we do algebra on it, which is really just taking steps to always have a truth that never changes. The way we do this is we always do the same thing on both sides of the equal sign. So to get x by itself, that's what we're trying to do, is we're trying to get this variable by itself. We need to get rid of this plus 3. The way we do that is we do the opposite, or what's called the inverse operation. So what's the opposite of plus? The opposite of plus is minus. So I'm going to subtract 3. Whatever we do to one side of the equation, we do to the other side of the equation, we subtract 3. Now what do I get? Well, the 3's cancel. Plus 3 minus 3 is 0. And so it pretty much just goes away. And we get only x by itself. On the other side of the equation, we have 7 minus 3. 7 minus 3 is 4. And that is our answer. And it was what we wanted, what we found before, right? We found that x equal to 4 gives us a true statement, so that's what we want. And this is how we solve a single step for addition and subtraction. Making a little bit of room. Let's look at the next one, which was 3b equals 15. Three is multiplying b here, so to get rid of it, we're going to divide by 3. Whatever you do to one side, you do the other side. And 3 divided by 3 is 1. 1 times b is just b. So it gets b by itself. In other words, they cancel. We get b equals 15 divided by 3 is 5. And that's what we found before, right? b equal to 5 is what we found. So that's the solution there. So one-step equation is where you only have to do a single operation, and that gives you the variable by itself. All right, let's look at some of these problems. M minus 5 equals negative 2. You can set it up like I did before with the vertical line here, but it's the same kind of idea. For here we have m minus 5, so the 5 is subtracting the m, so the opposite operation is plus. So minus 5 plus 5, but this is really all we're doing here is saying m minus 5 plus 5 equals negative 2 plus 5. All I've done is add plus 5 to both sides. As long as I do it to both sides of the equation, I do not change the equation at all. I'm not changing anything. I'm just adding in a single part that balances on both sides of the equation. However, I do this so that the negative 5 and the plus 5, which are like terms, cancel, and we get m by itself on the left-hand side of the equation. Negative 2 plus 5 is 3. You can always check your work. 3 minus 5. That does, in fact, give us negative 2. So we've got a true statement here. M does equal 3. Here we have z plus 3.2 equals 5.7. We're going to subtract 3.2. That's because it's adding to 7, so we're going to do the opposite, or the inverse operation, which is subtraction. So here we have z equal to 5.7 minus 3.2. That gives us 2.5. You can do that in your calculator if you're not sure about that, but that's what that gives you. And you can always check your answer if you want. This one I know is true. The next one, we want to get q by itself. So in this case, we're working on the right-hand side. We still solve this the same way, right? There's the equal sign. We're going to add 1 1/4 to both sides. So now we get 5 plus 1 1/4 equals q. Okay, so now we need to actually combine 5 and 1 1/4. Multiple ways you can do this. You can rewrite this as a improper fraction, get common denominators and solve. We can also just add these mixed numbers together. This one's actually quite simple to do because 1 1/4 is really just the same thing as 5 plus 1 1/4 is the same thing as 5 plus 1 plus 1/4. That's all a mixed number is. It's just a fancy way of saying the whole number plus the fractional part. But in this case, this is really just easy. This is just 6 1/4. We could say q equals 6 1/4. Maybe that's useful for a measurement saying there's 5 inches plus 1 1/4 inch. Then we have 6 1/4 inches finally. That's why you might want to leave it as a mixed number, whatever the situation calls for. All right, think about this one for a second. N plus 7 equals 3. How do we get n by itself? Well, 7 is adding to it, so we need to subtract. 3 minus 7 is negative 4. Okay, the next one, we have b plus 2 1/3. So how do we get b by itself? We need to subtract 2 1/3. You see, I'm always doing it on either side of the equation. That's how you balance it. That's how you always make sure you're not changing the equation. You're just changing how it looks, I guess. So we have 5 minus 2 1/3 equals b. Most of the time, I do not like working with mixed numbers. The previous one was very simple to where you can do it. In this case, we're subtracting. You can do this by using mixed numbers, but it's going to be, in my mind, it's easier to change it to improper fractions. So I'm going to flip this equation around just so it's easier to write, but I'm not changing anything. I'm flipping the sides of the equation. I'm saying b equals 5 over 1, which is just 5 over 1, minus 3 times 2 is 6. 6 plus 1 is 7, so we have 7 over 3. So this is the exact same equation. I haven't changed anything. I just flipped which side b is on. Now I can get like common denominators. It gives me 15 over 3 minus 7 over 3. And now I can subtract the numerators. 15 minus 7 is 8 over 3. And since we started with mixed numbers, maybe we should finish with mixed numbers. 3 can go into 8 2 times. So b equals 2. 3 times 2 is 6. 8 minus 6 is 2. So we have 2 and 2 thirds. You can always check your work. 3 times 2 is 6. 6 plus 2 is 8. So this is also the same thing as 8 thirds. So that's the solution. Okay, so that was addition and subtraction. You see, all we did here was really just add a number to the other side or subtract it to the other number to the other side. This next section, we're going to multiply and divide. So we have 12 times y equals 36. To get y by itself, we're going to do the inverse operation of multiplication, 12 times y. The inverse is division. That's what gets rid of the 12. So we have 36 divided by 12, which is 3. All right, 3 times s equals negative 57. Divide by 3 because the inverse of multiplication is division. And negative 57 divided by 3 is, I think it's 19, but we will check. Yeah, it's negative 19. Negative divided by a positive is negative, and 57 divided by 3 is 19. So we have s equal to negative 19. You can, of course, check your work. 3 times negative 19 is going to be negative. 3 times 19 is 57. Okay, for the next problem, we have x divided by 4. We're moving into a point in our mathematics where we don't really use the division symbol anymore. There is sometimes we use it, but normally we use fraction bars for division. It's a much cleaner way of writing division, and it's easier to work with when you really know how to use it. The fraction bars are generally just better to work with. In this case, you see that it's used as a division. X divided by 4 equals 3. The inverse of division is multiplication. So you need to multiply by 4 to both sides. That's what cancels with the denominator. So now we have x equal to 3 times 4. 3 times 4 is 12. All right, next one. 1.7 times w, I'm going to divide by 1.7 on both sides of the equation. 6.8 divided by 1.7, that gives us 4. Last one here, we have a divided by 10 equals 15. So we need to multiply by 10 on both sides. Here we have a equal to 15 times 10, which is 150. I want to do one more problem here before we go application problems. Sometimes you'll see this type of problem. I've seen students get this wrong before. Now I just wanted to cover it. We have negative 5 plus k equals 10. Now you may be thinking, well, to get k by itself, they're adding together, so I'm going to subtract. The problem, however, is that this negative 5, this is like it's subtracting 5. Okay? Now you can subtract, if this is addition, you can subtract, but you'd have to subtract out a negative 5 to both sides, which is the same thing as plus 5. Whenever you have a situation like this where you have a negative number and then the variables afterwards, it might actually be easier for you to know what to do by rearranging this side of the equation. And all you have to do is make sure the blocks are together. The sign in front of it is with the number. I'm just going to flip these blocks around. So I get plus k minus 5 equals 10. Plus k is like plus 1 times k, which is just k. There's no reason to write a plus in front of a number when there's nothing else in front of it. So we have just k minus 5 equals 10. And now you can see here we have to add 5 to both sides to get rid of it. You can, of course, do this in the very beginning. What you're looking for isn't the operation between the variable and the number. You're looking for the sign in front of the 5. This only happens when you're doing addition and subtraction. Multiplication and division, right? I could have k times -5 or negative 5k. Both of these are quite clear that it's multiplication here, and in both cases, to get rid of it, we divide by -5. You can see here that it's multiplication because the k is right next to the parenthesis group, which means multiplication. And right here, the -5 is right next to the variable, which means multiplication. So it's a little more clear when you're doing multiplication and division. Addition and subtraction is sometimes where the error happens. But if you do have addition and subtraction like this case here, all you need to do is look at the number in front of the number by itself, and we just add 5. That's because when that goes away, we have plus k, and k by its plus k is just the same thing as k. We have k equals 15. Just like down here, we had k equals 15. This bottom way, I think, is much cleaner and neater to work with. All you have to do is rearrange the terms in the expression, which is fine to do. And in fact, if that makes more sense to you, I would suggest you do that. It's going to give you a better chance of getting the correct answer in the long run. All right, so I've got a few application problem. Let's look at them. The formula D equals RT is used to calculate the distance traveled by an object moving at a constant average speed R during an elapsed time T. This is the formula I used in the last video. D equals RT, or no, 2 videos ago. D equals RT. So we have, how long would it take a pilot to fly a distance of 1,240 miles at an average speed of 220 miles per hour? That's a rate. That's a rate of speed. So sometimes you don't know exactly what to do to start with this thing. But in this case, it gave you a formula, and it gave you pieces of information that you should be able to attribute to one of the variables. In this case, all we have to do is plug in the numbers in each part. So D equals 1240 and R equals 220. We don't know what T is, but we do want to know what T is. How long is the same thing as the time elapsed. So if we solve for T, that's how long it would take, and that gives us our answer. Well, in this case, we have just a two-step equation. The parentheses here, we can drop them. It's the exact same expression here. And you see that T and 220 is multiplying. So to get it by itself, all we have to do is divide by 220. That gives us T equal to 1240 divided by 220. That gives us 5.636363. I'm gonna round up to 2 decimal places. 5.64. And that's going to be in hours because we have miles and miles per hour. This will be in hours. The frequency F in waves per second and the wavelength W in meters of a sound traveling in air is related by the equation F times W equals 343, where 343 is meters per second, is the speed of sound in air. Calculate the wavelength of a musical note with frequency of 200 waves per second. So typically frequency is in the unit called hertz, and hertz is the same thing as like think of it as waves per second. Waves doesn't really have a measurement. It's kind of like a unitless thing, but the per second is what gives us the hertz. Okay, so we are just trying to figure out what is the wavelength, and wavelength is W. That's what it says right here. We know what the frequency is. The frequency is 200 waves per second, or in other words, 200 hertz. And we also know this equation right here, that F times W equals 343. Well, if F is 200, and we want to figure out what W is, well, all we have to do is solve this one-step equation. Divide by 200. Now we get W equals 1.715. So that's the wavelength, and that's going to be in meters. So that's the wavelength of this musical note that's got a frequency of 200 hertz. All right, the amount of lumber in board feet can be expressed by the formula board feet equals T times W times L over 12. T is the thickness, W is the width, and L is the length. What total length, well, this is just the same thing as what is L. If a 1x6 board is needed for a total of 16 board feet. So 16 board feet, that's what BF is. 1x6, well, that's going to be the thickness and width. In this case, it doesn't really matter which one's which because we're multiplying everything on the top anyway. So it's not really important to designate which one's which if you didn't know. But thickness is typically the smaller number. And yeah, all we have to do is figure what L is. So again, you may not know what to do here, but we're given a formula. The board feet equals T times W times L over 12. And we know what pieces of this formula is. The board feet is 16. T is 1. W is 6. And L is what we're trying to find. So that's just going to be a variable L. And this is over 12. Well, if we simplify this right-hand side of the equation, we get 16 equals 1 times 6 is 6. And we can divide top and bottom by 6. We get 16 equals L over 2. And in this case, you'll see, well, this is a one-step equation. L is being divided by 2. All I have to do to solve for L is multiply by 2 on both sides. So L is going to equal 16 times 2, which is 32. And you'll see that the T is the thickness of the board in inches, which was given to us in inches here. W is the width in inches, and that's also given to us in inches. And L is the length in feet. So this is going to be 32 feet. Here's the last problem. We have a construction site. A winch is used to wind cable into a drum. And for the first layer of the cable, the line pole P, we have a line pole P of the winch is related to the diameter of the drum by the formula P equals K over D. P equals K over D, where K is a constant. In mathematics, K is typically used for a constant. These are constants that don't change or anything. They could be a lot of different things. There's a lot of constants that physicists have found, like permeability and permittivity of free space, things like that. But K in mathematics typically means it's a constant. It's a variable, meaning that we don't know what the constant is necessarily, but K is going to be a constant between every single situation. For instance, pi is a constant. It's always equal to 3.14. But we use the variable, the Greek pi symbol, to designate it instead of using the number 3.1415927, all that stuff. Anyways, P is a constant here. K is a constant, and we're trying to figure out what that constant K is, and it's going to be in foot-pounds. And we're given that P equals 5,400 and D equals 4. So P equals 5,400. K is what we're trying to find, and D equals 4. You see K is being divided by 4, so we need to multiply by 4. That gives us K by itself. Of course, I forgot to read the hint. And it says convert D to feet first. So this is actually wrong. That was my bad. Let me just convert that. That's not hard to do. If D is in 4 inches, there are 12 inches in a foot. So 12 inches is going to go on the bottom. 1 foot goes on top. You see the inches cancel, and we have feet. This gives us 4 times 1 is 4. 1 times 12 is 12, which is the same thing as 1/3, dividing top and bottom by 4. So D is actually the same thing as 1/3 foot. So here we have K divided by 1/3. We still solve this the same way. In other words, multiply by 1/3. That's going to cancel the division by 1/3. So now we have K equals 5,400 times 1/3. You can think of this as 5,400 over 1 times 1/3. That gives us 5,400 over 3, which is 1,800 foot-pounds.